Hello, hello. Hello, I want to do a quick sound check. Can people hear me? All right, welcome to this Intro to R and Data Science class, everybody. Good to have you all here. So just a very quick introduction about myself. My name is G-Pal. I started teaching these kinds of data science classes in YouTube starting last year around June. And the main reason I started this was I love live education, and live online education is so much more convenient. But I couldn't find any affordable live online education solutions myself. So I decided to teach data science because that was something that I was passionate about. So that's how this got started a year back. And I've been offering these kinds of periodic classes on YouTube and outside of YouTube as well. So what's the goal for this session? My goal is in this short 1 hour is to really help you jumpstart your R learning journey. So whether you have any kind of programming background or not, it really doesn't matter. My hope is that in this 1 hour, you gain the fundamentals, you gain a strong foundation of R that enables you to learn more on your own. So that's really the goal of this session. So what are we going to be learning today? The first thing we're going to be learning today is how R Studio works. So R Studio is the integrated development environment for those who, for when it comes to applying R code. So we're going to learn how that works. We're going to be learning the basics, things like how variables and data types in R work. We're also going to be learning things like how operators, how you can do mathematical operations using R, how logical operators work, how functions, how you can create functions, how you can apply functions, and at the same time, how data frames work. What are data frames? How can you do a little bit of basic plotting? And maybe if we do have some time, we can also focus on control structures that are things like how for loops and while loops work in R. So if none of that made any sense, don't worry, we're going to cover from the basics itself. So you're going to be good shape. So the first thing you want to do is you want to get an account on r dots. Let me show you the link here. So go ahead and go to this link, rstudio.cloud. So rstudio.cloud is going to be the place that we're going to be learning how to code today. The nice thing about this environment is that it's online, so you don't have to download anything. So go ahead and create an an account on rstudio.cloud. And when you're done, just sound out in the YouTube channel section, and then I can move on. So go ahead and create an account. When you're done, just give me a heads up, and then I can move on to the next part. So while you are setting up that account, let me just explain how this thing actually works. So if you want to eventually, right, you want to download RStudio on your own, I'm going to share with you notes of this class, and I'm going to give you instructions on how you install RStudio locally in your laptop itself, in your desktop itself. But for the moment, just to make things a lot faster, I recommend that you create an account on rstudio.cloud. It's free, it's super convenient, and when you're done, just sound out, and then we can take it from here. Okay, done? Excellent. So people seem to be done. Good. So if you're done, what I want you to do is go to this new project button, click that. Okay, this takes a little while. Let it load up. And then I'm going to kind of orient you around RStudio. So Here's the thing. R is the language that you're going to be learning. R Studio is it's called the IDE. And what IDE stands for is Integrated Developer Environment. So think of it this way. You can write your own script to run R, but this R Studio just makes it a lot more convenient, and it's going to be a lot more evident when it loads up. It enables you to track your variables. It allows you to see the plots that you have. It's a much more convenient way of writing R code. So let this load up. This does take a little while. Okay, in the meanwhile, let me name this project. So you can name this project whatever you want. Let's say I call it in class R intro practice. Okay, let this load up. It does take a little while. Okay, let me just refresh this maybe. Okay, anyone else having issues with this part? Okay. Okay, let me go back and let me open up. Okay, let's try this again. Okay, I'm gonna just wait for 10 more seconds. Otherwise, I have another environment that's already set up and I can get that going. Okay, quick question. Have you all been able to load up your R Studio environment? Okay, don't worry, it's going to load up. I have a preloaded environment here, so I'm just going to show you how that works. So let me explain what's going on here. Okay, so what you want to do is you want to go to File, and then create New File, create R script, and then you're going to get this 4 panels lined up neatly here. So go ahead and do that. Go to File, New File, R script. Okay. So your R Studio is going to look slightly different because it doesn't have all these things populated. But let me explain what's going on here. So you should see these 4 panels, right? So let me explain what these 4 panels are. So this top left-hand corner panel, that's going to be the place where you're going to be writing your R script. So think of the R script as the instructions that you write on R itself. On the bottom left, that's called the console, right? That's going to be the part where you're going to be seeing the outcome of your script itself. So when it's executed, when you call the script, you're going to see the outcomes here. Then on the top right-hand corner, you're going to see this part called the environment section. That's where you're going to see what kinds of variables you have stored that are available in your environment in R itself. And then on the bottom right-hand corner, you're going to see all these different labels here. Files is keeping track of the files that you have in the project. Plots is going to be all the plots that you create. Packages are, I'm going to explain what packages are later, but essentially they are kind of functions put together. That's a very simple definition of packages. And these are the important things that you need to know. So as we go along, I'm going to go deeper into each one of these panels and you're going to gain experience. But I just want to do a quick check. Anyone else having issues loading up R Studio? Did you manage to get it? Okay, so it seems that folks have gotten it. Okay, so I'm going to keep going. So the first thing we want to do is let's write our first line of code in R and let's see how we can execute the code. So the traditional, let's start with the classic hello world line. So go ahead and type in print, right? and you're going to get a parentheses open up, create a double quotes, and then type in hello world. Okay. Now, when you want to execute a single line on R, what you want to do is you want to hit Command and Enter together at the same time. So go ahead and do that, and then you're going to see this pop out, right? You're going to see in the console, hello world is being printed out. So that's one way to execute your R code. So if you have just one line, you can just type in Command, Enter, and you execute the code. This print thing here is called a function. I'm going to explain that later. But for the time being, the key thing you need to know is the way that you execute R code is Command and Enter. That's one way to execute the code. There's another way to execute the code, and that's to hit this button called Source. That also executes the code for you. Suppose you have multiple lines, right? Let's create another line. Right? Let's say, hello world, I am learning R. Okay. Now, once again, if you want to just execute this one specific line, which is line number 2, you can just hit Command, Enter, and just that specific line is being executed here. But suppose you want all the lines to be executed, meaning you want R to print out hello world, and you want R to print out I am learning R. What you want to do is you just want to hit the source button here, and it's going to execute both the lines for you at the same time. Now, at this point, I want to also introduce you to the concept of comments. So whenever you write code, it's a good idea to leave comments for 2 reasons. First of all, chances are others are going to be reading your code, and you want them to be able to make sense of what you're doing a lot easier. The second thing is it's for you yourself, because chances are, when you look at code that you wrote a few months back, it's a bit hard to understand what you did and why you did what you did. So to make sense of that, it's a good idea to leave comments. And the way that you leave comments in R is by using this hashtag symbol, and then you type in your comment. In this case, this is a very simple program, so there isn't much to comment, but this is how you leave a comment. Okay. And when you leave a comment, even when you run the whole R script, it's not going to get executed, right? So the hashtag symbol allows you to leave comments. Now, this is so far we have learned how we can execute our code using the Command Enter method, and at the same time running the source method. Now, what I want to teach you is, the next thing I want to teach you is how variables work. So think of it this way. Let's just back up for a second. What is programming at a very high level? Well, programming at a very high level is all about data manipulation, right? You take in an input, you do some processing, and then you get an output, right? That's what programming is at a very high level. That's what programming is all about. Now, if you want to do that kind of information processing, you need some way to store the data. You need variables to store the data so that you can do the manipulation and then you can output it. Now, how do you store the data? The way that you do that in R is you start with the name of the variable. Let's say let's say we create a new variable called programming language. And the way that you assign a specific data, specific element, right, to that variable is you hit this symbol and dash, and then you type in the variable. So let's say I type in R. Now, suppose I want to print this out. I type in the name of the specific variable itself. So now let's say I run source. You're going to see R being printed out. So the key thing you need to remember here is, if you want to assign a specific value to a variable, you start with the variable name, and then you use the less than dash symbols, and then you put the value here. Now, in this case, we used a string value, or as it is known in R, it's a character. So you can also assign numerical values to your variable. So let me show you an example here. Let's say we are going to create this variable called length. Okay, and let's say we assign it a value of 5, and let's say we also have this variable called width, and let's assign it a value of 8. Okay, now what you can do is something interesting here. You can create a new variable, let's call it area, that is a multiplication of the length multiplied by the width. Now we're going to go much deeper into how these mathematical operations work, but just to give you a glimpse of how that works here. So essentially we're creating a variable out of these two hard-coded variables here. So now if you run this, right, let's say I go print area, it's going to show me 40 because you're multiplying 5 by 8. Now I'm going to show you a quick hack here to make your life a lot easier. So instead of writing print, what you can also do is you can just put this, you can just wrap your variable in parentheses and it's going to print out the value of that variable as well. So that's a quick hack. Now, there are a couple of rules when it comes to creating names of variables, right? So the first rule is when it comes to variable naming is you cannot start with a number, right? You cannot start with a number. So you can't create a variable like 2L or 2Y. No, that doesn't work. So that's the first rule. The second rule is you cannot use reserved. You cannot use reserved keywords like if and for and true, right? So there's certain keywords that have been reserved in R, like if, for, true, false, and we're going to explore some of these keywords later on. So you cannot be using these reserved keywords. So that's something that you want to take into account as well. Chances are you're not going to bump into them. It's very improbable that you would bump into them, but it's good to keep that in mind, right? Now these are hard rules, right? So you can't start with a number, and you can't use keywords. There are a couple of guidelines when it comes to variable naming as well. So first of all, you have to remember that R is case sensitive. So that's something that you want to keep in mind. The second thing you want to keep in mind is that it's better to go for short names that are expressive. So imagine in the case of length, I mean, you could have, length is very clear, right? If somebody else looks at this code, they understand what's going on. So you want to go with variable names that are expressive, that are clear. Okay. So these are things that you want to keep in mind when it comes to the names that you choose for these variables. So far, what have we learned? We have learned how to write basic R code. We have learned how to execute the code. We have learned how variables work. Now, think of these variables as storage boxes, right? But what are they actually storing? So in this case, we just looked at how they're storing what we colloquially know as numbers. They're storing things like characters here. So the next thing we want to learn is what are the different data types in R, right? So that's the next thing that we're going to be learning here. So what are data types in R? So that's the next part that we're going to be exploring. So before that, a very quick, I want to run through the concept of how vectors work. So vectors are the most simple data structure in R, and they contain elements of the same type. So I'm going to give you an example, show you how that works, and then we're going to dive deeper into these different data types like integers and characters and logicals and so on. So let me show you how vectors and data types work. So as I said, a vector is essentially a very simple data structure that contains elements of the same data type. So let me show you an example, and it's going to become a lot clearer. So let's say we create this vector called exam scores, and I'm going to explain this. Just give me a second. Let's use this function called C, and then let's type in a couple of values here: 92, 93, 93, 93, 92, 89, 97, and 98. Okay, so let me explain what we just did here. So when we have this C function, what C stands for is it's concatenating, right? It's joining all these different elements together, 92, 93, 93. It's putting all these elements together, and we have this vector in R. So as I said, vector is essentially a very simple data structure that contains elements of the same sort. So in this case, we have a vector with all these numbers. It's also possible that we have a vector with just characters. So imagine we create a new vector called student names. And let's go concatenate, and let's say Andy, Bob, let's just go Cindy maybe. Okay. So this is a vector with just characters, right? So in this case, these were numbers. In this case, these were essentially characters involved in this. Now, how do you find out the specific data type that's in these vectors? Well, the way that you go about doing that is you use this function called class. Okay, so let's say print class exam scores. Let's say we run that. Okay, and it tells us that the data type inside this vector, inside this specific vector is numeric, right? And likewise, if we run the same function, so we're going to be exploring what functions are later, but just think of a function as something that takes in an input as a specific method of processing that input and then gives a specific output. Student names. And now you find that this is a vector that's composed of character data types. So these are two data types that we have just taken a look at. We have looked at numeric. We have also taken a look at character. Apart from this, there are a couple of other major data types that you should be familiar with. So it's good to be familiar with another data type called integers. So an integer looks something like this. Let's say we get integer vector. So it's composed of things like 93L, 98L. So let me explain what's going on here. So L stands for literal. So what happens in R is that when you give it what seems like an integer for us, like 92, 93, 93 here, it actually takes it as a float, a double, meaning it assumes that there's like a decimal point. That's the way it processes it. But if you want it to be expressly just an integer, that's when you have to add this L letter next to the number itself. So in this case, now if we type in print class int vector, oops. Okay, we have to run this first. Command enter. Command enter. Right, now it tells you that this is an integer. So we've taken a look at numeric, we've taken a look at characters, we've taken a look at integers. There are a couple of others like complex numbers. Let me give you an example with that. Complex vector. So that's made up of things like 5 plus 9i. So these are imaginary numbers. Chances are you're not going to be encountering them often. It just doesn't happen all that often. We also have things like logical vectors, and that's composed of things like true and false, true, false, true, etc. So for those with programming experience at Python and other languages, you might know these as Booleans. In R, these are known as logicals, right? Another one is called raw, but it's very unlikely that you're going to encounter that. So these are the main data types that you should be familiar with. We looked at numeric, characters, integers, complex, and logical vectors. So these are the main data types that you want to be familiar with. And remember, when I discussed this idea of vectors, I mentioned that vectors contain elements of the same data type. So you can mix and match an integer and complex number and logical and a character. What happens when you do mix them is that R coerces them to become the same data type. So let me give you an example here, right? So let's say we print. Say we want to print the class of this specific. Okay, let me make it easier here. Okay, let's create this combined vector. Okay, and let's say it has names like Tesla. So these are all characters, right? And let's say you mix it together with numeric like 98.2. Okay, let's command enter so that this specific line gets executed. And the way that you know that this specific variable has been initialized is that when you take a look at your global environment, right, now you find that you see combined vector, right? That's what we created here with the character and the numeric value. Now, what's going to be the data type of this combined vector? Right. Oops. Okay, we have to put the class function here. It's going to be character. So what happened? So these two are characters, Tesla and Audi. The way that we created them, these are characters. But in this case, this is actually a numeric. But because vectors can only contain elements of the same data type, there's data type coercion, and this 98.2 gets converted to become a character here. So that's why you see 98.2 in quotation. So that's something that you want to be mindful of. So far we have been just taking a look at how data types and vectors work. Now, what's interesting in R is when you can perform mathematical operations on these data types, right? On these vectors, when you can use logical conditions to figure out what are all the values that are perhaps greater than 90 for this exam scores vectors, and so on. So you want to be able to do mathematical operations. You also want to be able to do logical filtering on your vectors itself, and eventually data frames and the bigger data sets that you have. So how can you do that? Well, for that, you need to understand how mathematical and logical operators work, and I'm going to show you how those work right now. So let me show you a couple of examples of these mathematical operators, and then it's quite intuitive. You're going to get a quick sense of how that works. So the mathematical operators in R are fairly intuitive. Most of the commands are fairly intuitive. Let me show you a couple of examples here. So the basic addition subtraction still applies here. So let's say we run print 3 plus 4, command enter. You're going to get 7, right? Let's say we want to run 4 minus 2, gives you 2. So nothing different when it comes to addition subtraction. Likewise, when it comes to multiplication and division, 5 times 2, 10. Everything is quite standard here. Right? Let's say we do 3 divided by 4. It's going to give you 0.75. Now, something that might be a bit more unfamiliar to you is exponents and how modulo work. So let me show you how that works. So let's say we want to raise 2 to the power of 2. You're raising the exponent. So you use this upper caret symbol. So this is going to give you 4. So this is an exponent. And let me also explain how modulo works. So modulo, think of that as a remainder function, right? So imagine I run print 5 and this percent symbol divided by 2. So in this case, 5 divided by 2 gives you a remainder of 1. So that's why when you run this, command enter, you're going to see 1. So this might be a bit new. And for those from Python, you might remember modulo, but in Python, only just 1% symbol is used, but in R, 2% symbols are used. So that's a slight subtle difference in Python and R here. And as with any mathematical operations, any set of mathematical operations, the standard order of operations still apply. So imagine we have a sequence of operations like this, right? What's going to happen is it's going to say, look, priority goes to the division. So this is going to give you 3, and then the addition happens subsequently. So it's going to be 7. So my recommendation is when you have a string of operations, it's always a good idea to use parentheses so that people are able to parse what's going on and they can understand what's going on a lot easier. And it helps you debug as well. So in this case, if your intention was to add 4 plus 6 and then divide it by 2, it's always a good idea to use the parentheses liberally so that it's a lot easier to understand what is going on. And as I mentioned, what's nice in R is that it's when you can do all these mathematical operations, that's when it gets really, really fun. So let's say, and you can perform mathematical operations on vectors of the same length. So let me create a new vector called base salary, right? And let's just say 50,000, 60,000, and 70,000. Okay, let's initialize that, command enter that. Let's create a new vector called commission, right? Let's give these people 6,500, 6,000. Let's give this person 5,500. So there are 3 elements here, right? You have a base salary, 50,000, 60,000, 70,000, and then you have a commission, 6,500, 6,000, and then 5,500 here. Let's initialize this as well, command enter this. Okay, now let's say we want to calculate the total salary, the final salary, which is essentially an addition of these elements together, 50,000 with 6,500, 60,000 with 6,000, and so on. How can we do that? Well, we know how addition works here. It's just adding things up. So likewise, what you do is you create a new vector, and then you add these 2 other vectors up. So go ahead and do that. Okay, command enter this so this gets created. And now if you hit print final salary, command enter this, now you find that you see the addition here. 50,000 with 6,500 is 56,500, and likewise, so it adds up. The key thing you want to remember when it comes to doing mathematical operations on vectors is that they need to be of the same length, right? Otherwise, you have issues. So let me show you what happens if you don't have vectors of the same length and you're performing a mathematical operation. It's going to show you a warning. Let me show you what happens, okay? Let's take this out. Let's command enter this. So it gets initialized. Let's add this up again. Look at this warning message. It says, hey, look, when you're trying to do this addition, the lengths don't match up, right? The commission has a length of 2. Your base salary has a length of 3. So what ends up happening is if you do this, in the case because element 3 here doesn't have a corresponding value, you recycle and you add this number, element 1, to element 3, right? So to make that clear, let's run this print salary again. And now what you see is, yes, element 1 and 2 added up nicely, but for element 3, what happened was you added this same element 1 again. So you recycled the vector again. So that's not something that you want necessarily. So you want to be very, very careful. And you want to make sure that vectors are of the same length when you perform mathematical operations. So in this case, we did addition. Theoretically, you could have done anything else as well. So it's all fair game, okay? Okay, now, so far we have looked at mathematical operations, so you can perform mathematical operations on vectors. I also want to run through how logical vectors work. So remember, logical data types, these are the things that look like true and false, right? So these are the things that look true, like true and false. You can combine these things, uh, and you can essentially, it helps you filter vectors and your data frames a lot more granularly. So let me run through how logical operators work. So probably you're familiar with operators like greater than, less than, equal to, and so on. So let me quickly run through that. So that's a way that you generate logical data types like true and false. So let me show you how that works. So let's say we have 2 less than 3. That's obviously false. If you command enter that, sorry, yeah, 3 being greater than 2, yeah, that's true. So 2 is less than 3, so that gives you true. Let's say we have, let's say we get 1 less than or equal to 1. You command enter that, that's going to give you true. Let's say we run is 2 greater than 3, that's going to give you false. Okay, so these are fairly intuitive. But what I want to show you is the slightly more unintuitive comparison logical operators. So one thing you need to remember is the double equal sign. So we want to compare two data types, right? Two values, and you want to figure out are they equal or not. So the way that you do that is you use the double equal sign. Okay, is 1 equal to 1? That's what's being asked on line 20, and obviously the answer to that is true. Okay, so that's something you want to remember, the double equal sign. It's not 1 equal sign, it's double equal. And the opposite of equal to is not equal to, and the way that you do that is you use the percent, the exclamation point, and then equal. Is 2 not equal to 3? 2 isn't equal to 3, so that should give you true. And you can also reverse logical operators. So for example, you can say not true, that's going to give you false. Likewise, not false is going to give you true. Now the things that I'm going through right now might seem a bit arcane, but actually it's very important that you have a strong sense of how these logical operators work, because it's going to come in really handy when you filter your results later on, when you select for specific elements. So it's good that you have a good grasp of how these comparison operators work and how these logical operators combine together as well. So what you also want to understand is how when you have logical data types like true and true, false and false coming together, how do they interact, right? So instead of just looking at single conditions, often what you look at is you have multiple conditions and you want to figure out what do they evaluate to. So let me explain what I mean by that. So imagine you want to look at whether it's, imagine you have conditions like this: true and true. Okay, so if it's true and true, it's going to evaluate to true, right? So when it comes to the and symbol here, what you need to understand is that all the elements involved have to be true for the final outcome to be true as well, right? So what happens if you have false and true? Well, that's going to give you false, right? Right, we're going to have a small exercise later on, so if you have any questions, you can clarify, but I want to just quickly run through the other logical operators, like how true and true, how and or work together. And then if you have any questions, you can clarify at that point. So obviously, in the case of just to complete and, false and false is also going to be false. You just need a single false and it immediately becomes false when it comes to and. And you also have the or operator here coming into the picture. So imagine you have true or, so this is the pipe symbol, right? True or false. That's going to give you true. So when it comes to the or operator, you just need one part to be true and it immediately evaluates to true. So false or false is going to be false. Okay, and then true or true is also going to evaluate to true. So when it comes to true, the key things you need to remember is when it comes to or, you just need one true, and it's going to evaluate to true. But in the case of and, you need all the elements involved to be true, otherwise it evaluates to false. So in this case, what we have done is that we have just used two values and we have combined them. We have kind of put them together to look at the interaction, but theoretically it's possible that you combine an infinite number of these conditions and see how they evaluate. Okay, so let's say, so remember we initially I talked about how you can use these logical operators to filter, right? So this is when all these logical operators are going to become a lot more practical. So remember we created this vector called final salary. Okay, we have this vector called final salary. Oops. Grab this again. Okay, so we have this vector called final salary. Okay, we can use these logical operators that we just learned to filter the results. Let's say we just want to output the specific values that are greater than $60,000 in the final salary. Now, the way that you would do that is, let me explain. Let me give you the code, and then let me explain how that works. You would type in the specific original vector, right? And then you would use this square brackets, and then you would specify the condition. So in this case, I am saying, look, I want the final score to be greater than 60,000. Okay. And oops, no, this isn't final score, it's final salary. Okay, let's run this. And then what you find is that you're only getting the specific values that are greater than 60,000, because that's the condition that we specified. So this specific value, 56,500, is being omitted because of that. Now, what's going on under the hood here is when you use this condition, final salary greater than 60,000, what's going on is, let me show you how this actually works. When you specify this condition, what's going on under the hood is R is generating these logical data types, and it's feeding these logical data types into your vector, and it's only pulling out the elements that are true. So it omits the first one and it gives you the second and the third. So that's what's actually happening under the hood itself. Now at this point, I want to do a short kind of a mini exercise for you to kind of consolidate the concept of operators. So here are just three very simple questions for you to work on so that you can clarify. So take about 2 minutes or so to work on these. Let me type these questions out. So the first question is, what does 3 multiplied by 4 to 4 to evaluate to? So that's the first question I want you all to think about. So rather than typing this out, try to use what we learned, the flow of these operations, the sequence to the order in which these operations are supposed to be processed to figure out the answer. The second is, what does false, true, so work on these just for 2 minutes or so, and then I'll go through these questions. Okay, so spend about 2 minutes or so working through these questions, and then I'll go through them. And if you have any questions, feel free to message on the YouTube channel. I'll keep track of that, and I can answer any questions. Okay, and when you're ready, just kind of sound out on the YouTube channel section so that I know that it's time for us to run through this exercise and then go through functions and data frame next. Okay, I think people are ready. So, and in the interest of time as well, let me just quickly run through these 3 questions and then move on to functions and data frame. So this is the first question, right? What does this evaluate to? So the first thing you want to do is you want to look at the priority goes to the parentheses itself. So in this case, you have 2 plus 4, that adds up to 6. And then after that, all these other operations are of the same importance. So this evaluates to 6. So you have 3 times 4, which is 12. 12 divided by 6, which is 2. 2 divided by 2. So that gives you, let's run this. It gives you 1. So that's what you should have gotten. And the next part is this sequence of, let me just wrap this up there so you can print it up. Okay, so this is the next question. So once again, the priority goes to the parentheses. So, and you want to be kind of at a macro level, you want to make sense of what's going on. So there are 2 conditions here at the very high level, put together with this and so you want to evaluate those. So in this case, the left side, false or true. Remember, with or, you just need one side to be true. So this evaluates to true. Okay, and then you want to evaluate this second condition. And this second condition is nested. And the priority goes to the parentheses within this nested condition itself. So true and false, that's false. False and true, that's false. So in this case, this evaluates to true and false. And remember, with and statements, you need both sides to be true for them to be true. Otherwise, they're false. So this evaluates to false. If you evaluate this, it's going to give you false. And then finally, this condition. Let's run through this sequence. So in this case, we have 2 conditions put together with and we want to evaluate the left side first. So this is 3 exponent 2, meaning 9. Is 9 less than or equal to 10? That's true. And the next part is 9 remainder 4, that's 1. So this is true. So true and true, that gives you true. So let me just wrap this up in parentheses so I can print this out, and that gives you true. So once again, these exercises might seem a bit arcane at this point of time, but after a while, when you start applying filters and trying to sort out your data sets, it becomes really handy. So in the interest of time, I'm going to keep on moving. And next, we're going to be learning how functions work. So all this while, to some extent, we have already been applying functions like print, functions like the C, which stands for concatenate. So what are essentially functions? Think of functions as prepackaged pieces of code, right? They take in an input, they have a specific way of processing the input, and the output, and then that's what you get out of the function itself. So R comes with a bunch of predefined functions that make your data analysis a lot easier. So let me run through a couple of predefined functions in R. So you have things like round. So imagine you have round 9.32, right? So this is a function. Let me explain what's going on. It's taking in two arguments. So with functions, what happens is whatever I colloquially refer to as input, these are called arguments in functions. So they take in specific arguments and they output a specific value. So in this case, this function, the way it works is it takes in the initial argument, it takes it in, and then it rounds it up to the number of decimal points specified in the second argument, right? So in this case, 9.32, if you just specify 2 dp, it's going to give you the same output. But if it's 1, it's going to round down to 9.3. I'm going to show you a bunch of other neat functions very quickly. You can read about you can read about these functions via Google. If you type in predefined functions in R, you can find a bunch. But I'm going to just show you the main ones. So min is an important one. So imagine we use min, and we have this vector called final salary. It shows you the lowest value. You have max. Okay, that shows you the highest value in the vector. You have median. Okay, that shows you the point that's in between. And then you have mean, which is essentially the average. Okay, and then you also have range, which is going to show you the lowest point and the highest point. So these functions come in really handy when you have a large data set. Now, predefined functions are great, but what happens if you want to create your own function? How do you go about doing that? Now, the way that you go about doing that is, let me show you the syntax of a function in R. So the way that it works is you have the name of the function, okay? And then we use the symbol that we use for assignment. And then you type in function, you type in the arguments that you want to take in. So these are the inputs that you want to take in: argument 1, argument 2, and then you want to do whatever processing you want to do, and then you want to return a specific, let's say in this case, we want to type in arg1 plus, let's say we want to return arg1 plus arg2. I mean, you don't necessarily need to return this specific value, but you want to return a specific value. So that's the architecture of how a function looks like in R. So let me show you a specific example here. Let's say we want to create a function that allows you to multiply numbers together. Okay, I'm just going to give you an example here very quickly. Let's say we call it multiply num. We use the assignment symbol, and then we use function, and it's going to take in, let's say, 2 arguments. Okay, it's going to take in num1 and num2. So the thing when it comes to arguments is you can use whatever name you want, but these are the names that you need to use inside of your function, inside the scope of your function itself. So in this case, I've named these arguments num1 and num2, and let's say what I want to return is num1 multiplied by num2. Okay, and you want to register this function. So the way that you do that is you highlight and then you hit Command Enter. Okay, and then let's run this right now. Go multiply num, so we go 3, 4. It's going to give you 12, right? So now what's happening so this is called calling the function. You're executing the function. You're calling the function. What's going on is it's going to feed these arguments that you just gave, these inputs, into the function, right? And it's going to do the processing, and then it's going to give you the output itself. So that's what's going on here, right? The best way to learn how functions work is to practice itself. So I have a mini exercise that's going to take about 2 minutes for you. And what I want you to do is create a tip calculator. this up here. It's easier. So create a tip calculator that takes in two arguments, the bill amount and the tip percent, right? And then you want to output the total amount that needs to be paid, right? So essentially create a function that takes in the bill amount and the tip percent as two arguments and then outputs the total amount to be paid. So take about 2 minutes to work on this, and then I'll go through this, and then we'll go through how data frames work. And when you're done, just sound out so that I know that we can move on to data frames. And if you have any questions, feel free to ask me on our YouTube channel right now, because I'm monitoring that and I can help you out. And if you have any questions, feel free to ask me Okay, I think people are slowly getting done. I think they're close to done. That's great. So let me go through the possible solution to this practice exercise. Okay, so essentially we wanted to create a function that takes in two arguments, bill amount and tip percent, and then output the specific amount. So let's call this, so the first thing we want to do is we want to come up with the name of the function. Let's just call this tip calculator. Okay. And then let's assign this. So what we want to do is we want to use the syntax. We want to say function, and we want two arguments, right? So we want it to be descriptive. So let's just say bill amount and tip underscore percent. Okay, and then you open up the curly braces and you want to do the processing here, right? And let's say we say return. It's going to be bill amount multiplied by, in the parentheses, it's 1 divided by tip percent divided by 100. Because I'm assuming here that the person is just going to give it in percent itself, so 20%, 30%, whatever. So we want to divide it by 100, add it to 1, and then multiply that. So let's go ahead and register this function. Okay, and then we want to invoke, we want to call this function right now. Let's say we have 100, and let's say the person is very generous, they give them a 30% tip. So that makes sense here, right? The tip is 30% of 100, which is 30. You add that with 100, you get 130. Now, this isn't the only way to do it. There are many ways of doing it. I just wanted to show you a way of one way of doing it. I want to move on to the idea of data frames very quickly, because that is when you start applying all that you have learned and you see the practical side of R. So just stick along. I'm going to run through that, the most important things with data frames in about 10 minutes or so. So now, what is a data frame? So at a very high level, It's essentially rows and columns put together. Think of your normal Excel spreadsheet. So it's essentially something like that. This is a gross simplification, but this is a good working model to have, right? So the thing with data frames is that you can create them manually from vectors itself, but chances are you're going to be downloading data from a CSV file or a database like Postgres. So that's going to be the source for your data frame itself. R does come with its own preloaded data sets. It has a bunch of these data sets. You can Google them later. But today we're going to be exploring this one data set called empty cars, which essentially looks at the performance of cars. And this was from a few decades back. So the way that you get these data frames in for your analysis is you say library data sets. So that's going to be the package you're getting that in. You invoke that. And then you say data and the name of this specific preloaded data set. So R, as I mentioned, comes with these preloaded data sets. It's called empty cars. Load that up. Now, whenever you load up a data set, what you want to do is you want to get a sense of what's going on. And there are a number of ways that number of functions that you can use to get a sense of what's going on. One very handy function is called head. It's called head empty cars. It's going to show you the first 6 rows of that specific data set. So in this case, suppose you don't know anything about this data set itself. We're starting from scratch. It helps us develop an intuition of what's going on. So you see the names of car brands, MPG. So we know this is mile per gallon, cylinders. This is horsepower. This is weight. Now, some of these acronyms are intuitive, some of them are not. So if they're not intuitive, what you do is you say, go to empty cars are data set. Let's do that. And this is a explanation of the different columns, what's going on, right? We're not going to need every single column, but I'm just saying when it comes to these preloaded data sets, not all of the column names are intuitive, so you might need to read up about them. Okay. So head is super helpful. The opposite of head is tail, so you can also do that. Okay. If you run tail, it's going to show you the bottom 6. If you want to have a very high level sense of what's happening in the data set itself, you use this function called structure. It's just str. So type that in. It's going to tell you things like how many rows you have, how many columns you have, what data types you have in the data set itself, the data frame itself. So when you run structure, what you find is that it tells you, okay, you know what, you have 32 observations. So these are the number of rows of 11 variables. So these are the columns. And these are the columns, right? MPG, CYL, HP, WT. And it gives you a sense of what these values are. And it also tells you the data types in each one of these columns. And if you want to get the specific number of rows, you use this function called nrow. Okay, you run that. And if you just want the specific number of columns, so in this case we have 32 rows, if you just want specific columns and call empty cars, it's just going to give you the specific number of columns. If you want a kind of a statistical summary of what's going on, right, what you do is you say summary empty cars. You run that. Okay, now what you find is that for every single column, right, MPG, cylinder, horsepower, etc., it's showing you important data points like the minimum, median, mean, maximum, the quartile points as well. So this is helpful, especially when you have a very large data set and you're trying to develop an intuition of what's going on. You want to make sense of what's going on, and summary is a very helpful function when you do that. Now, just as with vectors, you can also subset your data frame, right? Suppose you just want to get the first two rows and you want to get all the columns. How would you go about doing that? So let me show you the example, and then it's going to make a lot of sense. So let's say you just want the first two rows. So for that, you type in the data frame itself, and then you type in 1, 2, comma, and just leave it empty. So the first part here is the rows that you want to pull out, and the second part here is the columns. So when you leave it empty, R is going to take it as, okay, this guy wants all the columns here. Okay, you get 1 and 2. The key thing I want to emphasize here is indexing in R starts with 1. So in many other languages like Python and Java, it starts with 0, but in R, it starts with 1, and it's inclusive. So in this case, when you have when you're specifying the sequence here, it's 1 and 2 that's being pulled out. The first and second rows. Suppose you want not just the first and second row, but you only want the first 4 columns. How can you do that? Let's see. Same thing. Let's say first 2 rows, and then you specify the columns. Right? In this case, let's say I just want the 4 columns. I'll specify 1 to 4 here. Now, chances are when you want to subset your data frame, you're going to be subsetting it based on specific criteria. Now, for example, let's say we have this column called MPG. Maybe we want to create a new data frame that has only the cars that have a mile per gallon less than 20. Right? Maybe we want to do that. The way we would do that is we would use this function called subset. So let me show you an example here. So let's say we create this new data frame called all sub 20 MPG. Okay, so and we're going to assign it, and we're going to use this function called subset. And the subset, when it comes to subset, the very first argument that it takes is the initial data frame itself. So in this case, it's empty cars. And then what you want to do is that you want to specify the condition. So in this case, I said I want MPG less than 20. Okay, so let's run that. So now we've created a new data frame where only the cars that have a mile per gallon less than 20 are inside it. And let's say we want to test it. We say print all sub 20 MPG. Now when you take a look at the MPG, it's all less than 20. So now we know that this is working. And just to add just one more wrinkle to this, so this is fine. With 2 arguments, you are able to create a new data frame, based on a specific condition. But let's say you want to get just specific columns into the new data frame itself. So the way that you would do that is, you would add a new argument, okay, and you would say select equals C. And let's say for this new data frame, you just want a couple of columns like MPG and WT, which is the weight. Okay, so now if you run this, okay, let's print out this new data frame again. It's only going to show you the mile per gallon and WT. So because what we did here was with this new third argument, we are saying, look, I only want the rows which meet this specific condition, and just give me these columns. So that's what's happening with subset. The thing I want to also emphasize here is that there are specific packages like dplyr and tidyr that make it a lot easier for you to filter and make sense when it comes to data manipulation of R. But it's good to know alternate ways of doing these things as well. Now, I just want to quickly show you how plots work. But before that, if you want to get just the values in a specific column, so in this case, let's say I just want to get all the MPG values or the weight itself in a specific data frame, what you do is you say print, start with the name of the data frame. Let's say we go with empty cars, which is the main data frame that we have, and you use the $sign, and then you enter the name of the column. Okay, and when you do this, what's going to what you're going to get is a vector with just the values for that specific column itself. Okay, so that's what's going on. Now, I want to very quickly show you how plotting works so that you get a sense of how data analysis in R can work here very quickly. So plotting is a big topic unto itself, but I just want to show you an example plot just to whet your appetite here. So imagine we want to plot, let's say we want to plot the relationship between the weight of the cars and the mile per gallon. So meaning you want to see, as the weight increases, does the efficiency, the fuel efficiency decrease. So if you want to do that, the first variable is going to be what needs to go into your x-axis. So that's going to be empty cars WT. And your y is going to be your mile per gallon. So we say empty cars MPG. Okay, let's just run this first. Okay, so this graph obviously doesn't look neat, but it gives you a sense of what's going on, right? You see the relationship here. As the weight increases, and just in case you're wondering, this weight is in 1,000 pounds. As the weight increases, what you find is the fuel efficiency decreases. Now, if you want to beautify this a bit more, you can use extra arguments here, like main, is an extra argument you can use. You can say relationship. It gives it a title. And once again, if you're wondering, how I find out, how do you go about finding out these extra arguments and so on? It's actually Googling it. It's also taking a look at the documentation itself. They will specify the arguments that are compulsory, arguments that are up to you as well. Right? So in this case, main is an argument that helps us create a title for the graph itself. So relationship between weight and MPG. So now if you run this, you're going to see the title pop up. Okay, now you see it popping out. Okay, and just two more arguments very quickly that you can use to beautify it just a little bit more. And these are called X lab, which stands for X label. You can have car weight. Right, let's say this is 1,000 lbs. Right, and let's also create, take this out. Okay, and let's also create Y label, which is your PG. Now you're going to get the X label and the Y label as a result of this. I have come up with a couple of questions just to stretch your understanding of data frames. We are running out of time, so let me just leave it here so that if you want to work on it, you can work on it, and we can discuss later. So I'm going to leave these questions for you here, right? Okay, so these are some practice questions that you can actually work on to consolidate your understanding of how data frames work. So if you want to work on these problems, you can always rewind to this specific time and take a look at these questions. And if you have any issues working through these problems, you can always message me. And we also have our Discord community channel that you can take a look at. So what's next when it comes to these classes? So first of all, I'm going to be sharing my notes from these classes with you all this evening. So I'm going to compile that, and I'm going to send those notes to you via email. And if you have any questions, feel free to post them on our Discord server. So you can find the link to the Discord server here. I've left them on the YouTube description itself. And specifically, if you have any questions, post them on the programming exercises channel here. So I'm going to be hanging around here, and others are here as well. So if you have any questions, we can help you out. And specifically next week as well, I have a couple of classes going on, and you can take a look at those classes on hackhour.co. So you can take a look at the classes that I'm offering next week as well. So that is it for our very quick introduction of Intro to R. If you have any further questions, feel free to message me via email. You have my email, or you can also message us on our Discord community channel. That is it, everybody. Thank you so much.